All right. Can everyone hear me? Okay, I'll try not to mumble. It doesn't sound like the acoustics are that great. Hey, I'm Craig. I'm the founder CEO of a company called StackLock. And I'm here to talk a little bit about the intersection of models and real-world systems. So, like, really looking at some of the mechanics that are necessary to create agentic systems or assistive systems that do real work in the real world, in enterprise environments. And, you know, I've been in technology for quite a while. Like, as a sort of hint, my first project was working on the clustering technology for Windows NT 351. So it kind of dates me a little bit. And I've, thoroughly enjoyed distributed systems as a sort of foundational part of my life. That journey has taken me through building a cloud product with Google Compute Engine, starting the Kubernetes project, kind of really focusing on open source with things like the CNCF ecosystem. And, for me personally, it's just shocking to see this fundamentally new capability starting to emerge. It's something I never necessarily dreamed I'd see as an engineer. And it really kind of enlivens one when you start to see these fantastic and fascinating new systems that are just so different to anything that you've worked with before, right? Like I've lived in the hard, cold, uncaring world of relatively traditional distributed systems. And now with transformers, you have this new capability. It's stochastic by nature. It's capable of doing wonderful things. You're able to extract and store semantic meaning from large data sets through the training processes. If you're clever about the way that you construct your prompts, you can generate semantically relevant and coherent responses to pretty much any question. And as we start to look at how this is going to change the enterprise IT space, I think everyone has their own theories, but there's no question that this is like an epoch boundary for humanity. I think our ages of humanity have been described by the dominant technology, Iron Age, Stone Age, Bronze Age, digital age, and now the AI age. And for this session, I want to just cover a couple of observations. And these are sort of maybe a little bit esoteric, and so I'll try to kind of ground it and make sure that it's sensible. And I'd like to just leave you with a couple of really practical things that you can start to explore, hopefully, with myself and my team in the community, as we work to bring a lot of these capabilities to organizations through the lens of Apache 2 open source software. And the first observation, and this, it's maybe sounds a little mundane, but these models deal with semantics. The whole training process is effectively extracting semantic meaning from large data sets. The whole inferencing process is effectively taking some amount of context and hopefully that semantically rich context and generating a plausible sounding result from it. And to create great results, semantically optimal output is going to require semantically optimal input. And I'll kind of snap into that. And stochastic processes, these are probabilistic processes. These systems work on the system of collapsing down a probability field, sort of one token at a time, effectively, to generate an optimal output, are by their nature random. And so you have to kind of account for that as you start to build with them as well. And so the starting point for this is, I want to just talk a little bit about context real estate. And how many of you have read that paper, The Bitter Lesson? I don't know if this is something that's familiar to folks. Okay, let me just step way back. How many of you are actively working on AI-based systems right now? How many of you are merely AI curious? How many of you don't care about AI? Okay, I'm glad, because I'd be like, what are you doing in this room? But as a starting point, I take a somewhat deconstructionist view of the use of these models. Like, there's a lot of people out there writing papers around agentic orchestration, reflection patterns. Here's how I set up this system that uses reflection to create this amazing outcome. And there's a paper that was written some time ago called The Bitter Lesson. I'm going to kind of appropriate from it a little bit. But the view was this, like, the rate at which these things are progressing means that at the end of the day, whoever can bring the most computational resource to deploy is going to create the most value. And so for a real-world organization, what that really means is, in the short horizon, it's safe to bet that whatever you're investing in from a agent-building perspective and the subset of workflows that you're going to be constructing will ultimately be subsumed by the frontier model providers. They will simply do a better job. They have access to more training data. They have access to more resources. They will integrate capabilities into that system that by the time you've got it working, the frontier model will have overwhelmed you, right? Like that's the sort of bitter lesson. And what does that mean for real-world organizations? What is the most leveraged thing you can do right now? Well, it's about the context real estate. These models take context. They render plausible results based on that context. If you want to succeed as an organization, being able to generate optimal context is the starting point. And that context real estate is finite. You know, we talk about like, oh, context windows are exploding. We can put 100,000 tokens into this context window and get results. You don't want to just put 100,000 tokens into the context window. To get the best results, you want optimal semantic richness for the task at hand in the context window. And so, okay, how many of you know what MCP is? Okay, awesome. Yeah, so think about it as a USB-C that enables you to connect real-world systems and models. It's a bridge between those systems, enabling access of context, context acquisition, and enabling the ability to start invoking tools, so actually enabling these things to do real work. And it's a lovely way to start accessing non-parametric data, right? So you live in the real world, most of your data sits behind your firewall, or it's in your virtual private cloud. How do you start to create access to that data so that these AI systems can start to reason about it and they can start to solve problems? And a practical path to do this is MCP. It's effectively a protocol that's optimized for exactly this purpose. But it is unfortunately also a path to context pollution. And this is not something that a lot of people realize. And I'll give you a very kind of specific example. Oops, too many slides. So here's a real world example. You know, developers fall in love with these tools. Like, hey, I can stitch this thing into Figma and suddenly it can interact with designs and I can just, you know, vibe code and chat with this thing and it will start to actually interact with Figma for me, or GitHub, etc. What folks don't realize is that every time you're connecting one of these servers, what are you doing? You're adding context. Every tool includes a description. Every one of those descriptions gets sent to the model every time you interact with the tool. So you start looking at like context consumption as you start wiring in these types of tools, and it gets expensive really quickly. So this is a real world example I just pulled from a blog post just to kind of illustrate this example. I've had similar experiences myself. And so when you're starting to think about, okay, I want to start building these types of systems for my team, I want to start connecting them to real world data, you also need to be very thoughtful about how are you using that context real estate. And you know, something that, you know, this is something we've built, and this is kind of an invitation to have a forward-looking conversation about this. But, you know, an approach that I've seen work really well, this is something that we've done ourselves. We've actually built this system. It now exists out there in the real world. You can play with it yourself. Is using a meta server. So this is kind of an interesting way to start saying, hey, I don't want those tool descriptions to show up every time I'm invoking a model. You know what I'd like to do? I'd like to render it down to really just 2 endpoints, find tool, invoke tool. And then I can start to use a RAG system to, you know, capture those tool descriptions. And then, you know, when you are, you know, interacting with the system, or an agent's interacting with the system, you know, it calls the find tool. The tool presents the most likely tools based on semantic awareness of the context. And then it can, you know, call the invoke tool system to actually do the work. And this has been really interesting. Like, I did this myself the other day, and I basically installed Cloud Code. I added the GitHub MCP server into Cloud Code. And I wrote a single query, which was how many issues had the community filed around you know, like, what are the top open issues that exist in this repo. The input context window for that query with the GitHub server involved, just the GitHub server, was 48,900 input tokens. Drop in the meta server, I got the same results, but it was about 20,000 input tokens. So if you're actually on this agentic journey, starting to look at the behavior of these systems and ask questions like, you know, like, how am I using the context real estate? Are there systems that I can put in place that will start to create far more optimal outcomes? So this is, you know, part of our open source project Toolhive. You know, to take a look, we'd love to talk to you more about it. The other concept that I want to talk about, and you cannot see anything, okay. I vibe coded this graphic, and basically what it's supposed to be is a view of what I think of as entropy cascade. So this is the idea that, you know, LLMs, people talk about them as being reasoning systems, right? Like, hey, they're reasoning systems. They're not reasoning systems. They're emulating reasoning, right? So when you think about the way that these systems are working, I like to snap it back to, how many of you read Kanahan's Thinking Fast and Slow? Right, so in this book, he describes these two kind of patterns in the human brain. The sort of system one, which is a fast-thinking system, is the ability to extract semantic data out of signal very, very quickly by using a programmed neural net below your brain. And then system two, which is your slow reasoning system, where you can actually start, working through facts. And the truth of, these models is that reasoning is emulated, right? Like effectively, you're taking a prompt, you're constructing a plan, which is the most plausible plan based on what the user's trying to accomplish. You're running it through an iterative process, assessing the results at every stage and producing an outcome. And the problem is that it's stochastic by nature, right? If the planning step is stochastic by nature, guess what? You're going to start to see divergence in a variety of different ways. And so what organizations are investing in tremendously is this idea of evaluation as a framework. So the evaluation is the new unit test. You have to run evaluations constantly. And when you're starting to build an agent that is dealing with reasoning systems, there's this tuning process where you sort of gradually constrict and optimize across everything, the sort of system prompt, the workflow, the tool descriptions, everything that's involved to start to generate a bounding area where that agent is behaving in a way that is sufficiently consistent to perform that task at hand. The problem is that entropy finds its ways into these worlds, right? So it's not like, particularly when you're dealing with enterprise systems, there's a lot of different things that can change that will change the behavior. Obviously, parametric data changes, behavior changes. A tool description changes, behavior changes. User behavior changes, the behavior of the system changes. And so one of the things that I think is really important, particularly when you're looking at building this class of system that you want to run to create value for yourself is, how do you start to constrain the system in such a way that you're avoiding this entropy cascade? Like one obvious step that I'm starting to see popularized now is using non-stochastic processes to actually drive the planning steps, to at least have very high levels of repeatability. But the other thing that I've certainly observed is that if you're an enterprise and you want to build an agent, that agent has to interact with the system. And so typically, you will build an MCP server. Everything will be working fine, then suddenly someone adds another tool, or another tool, or another tool, or someone changes the tool description. Now suddenly all bets are off. And so one of the patterns that we've observed is, MCP itself is a source of significant entropy. It's a way to start obviously getting these systems working. But if that system isn't controlled, if it's not pinned, if tool versions change, you're going to see very, very different results from a workflow. And you're going to be in this eval hell where you have to constantly run and retune the workflow day over day to account for this introduction of entropy through things like changing tool landscape. And so this does create this really interesting tension when you're starting to look at the use of MCP tools between the tool's descriptions and the tool's capabilities being bound to a specific agent's behavior and a specific agent's need. And so it raises the question, do I have one MCP server per agent? Or do I have MCP servers that are effectively just serving my organization, and I have other ways to deal with the introduction of entropy as those things change, as they versioned, as their capabilities enriched? Or is it something in between? And I argue for something in between. And this is something that, again, my team is working on. And I'm not great at naming, but we think of this as a sort of virtual server construct. So the ability to start reasoning about something like an MCP server that's exposing tools and resources as being a building block, a composable building block that you can start to filter. So basically saying, hey, these are the only tools that are relevant to this workflow. I don't want to have to create another instance of the MCP server. I don't want to have to create another system to kind of deal with the authentication, authorization, observability, policy management, et cetera. I can just start to layer these things as common technology assets that can then be collected, grouped together, composed, and presented to the organization. So this is another concept that we've been working on inside my company and through the Tool Hub project that I invite you to just start a conversation. We love hearing from people. We like talking about these things. And so, thank you. I do invite you to check out this project Tool Hive. It's Apache 2 licensed open source. It's a project that we've been working on, since pretty much the beginning of the MCP, the evolution of the MCP standard. And it's also something that Red Hat's now working on as well. We're very proud to have a good set of Red Hat engineers contributing to the project, and a couple of them were recently made maintainers. We think that, it comes to, go far alone or, go fast alone or go far together. And, my experience in building platform technologies has been the community is the way to go. So please do join us, join the Discord, hit me up on LinkedIn. We'd love to talk to you more about these concepts. I think I've got a couple minutes, so if there's any questions, I'm happy to field them.